So this section will be called Cartesian equation of line, and that's the parametric equation. So it's an easy connection. Look what we do. Probably I should zoom in a little bit. Yeah. It's an easy one. So what you do is this. You take component representation for your A vector. So here vectors, all of them, I'm not sure if I said it here. All of them, they come from Rn space. So they have components, n of them, A, B, C vectors. All of these vectors, they come from Rn, so they have n components for A, n components for B, n components for X. Now what you can do, you can write this vector equation in per component form, and I did it here, look at this. So the left hand side of my equation, that's the vector with the components x1, x2, xn, these components. The right hand side of my vector, if I write this in per component form, and I write this per component form already like a single vector, the first component will be first component of A vector plus lambda times the first component of B vector. Second component similarly, A2 component plus lambda B2 component, and all the way down here. So my parametric equation for my line, in per component form, it just comes down to this. Now what I can do now, I can look at this per component equation separately, and I can solve them for lambda. All right? If I do that, that's my solution. Look at this. Lambda equal, from the first line, x1 equal a1 plus lambda b1. If I solve for lambda there, the solution will be this. Everybody agrees with that? Simple linear equation. We just take a1 on the other side, so it's x1 take a1, and divide by b1. If I do similar trick with the second component equation, x2 equals, if I do similar trick, it will be this one. If I do similar trick for every component, in fact, I will end up with dots for most of the components. The last component will produce this. Now, this bit is called the Cartesian equation of the line. As simple as this. So, parametric equation is this or this, depending on the setting. Cartesian equation is this. And the connection between them two, they clearly in front of you. For instance, if I want to produce Cartesian equation for this, if I want to produce Cartesian equation for this example, all I have to do, look what I have to do. If I want to produce Cartesian equation for the example on page 18.1, all I have to do, I have to write my Cartesian equation in this form. Look at this. A1 components, vector A components, they all here. Vector B components, they all in the denominator. And that would be the Cartesian equation corresponding to this example. For the other example, for the example 18, second one, on page 18, second one, if I just take it up a little bit, here's the components of the A vector in the answer. This is the components of the B vector in my answer. All I have to do, I have to write these components now in this form. And that will be the Cartesian equation of that line. So here's the writing. X plus 1, this is negative 1, on 5, y take 2, z take 6 on negative 3. That's the Cartesian equations for the same lines from these two examples. We stopped at the stage where I tried to explain to you why we call this Cartesian equation of the line. The reason for that is just actually when you look at such equation for the lines on planes. So when you look at such equation, when you live within R2 space, which effectively the plane you know very well, this equation will take the form very well known to you, and that's how it goes. So if you take your Cartesian equation of the line, and now you're looking at the two component vectors in R2, if you just, and you see, just to link this to the Cartesian equation you knew before, I just rename my components of x in a more conventional way, like x and y. No longer it goes x1 and x2, just x and just y. Now if you solve this identity for y, if you solve this identity for this variable, it's a bit of the arithmetic involved. I'm not sure if I did all of it here. Let's just see if I did all of it here. So no, I didn't. I just put the dots here. But I don't think it's a big problem for you. I think you can do it with no of my involvement at all. So if you solve here, well, it's easy actually, that you will come up with something like this. And that takes the form of the equation of the line you know from the high school, especially if you call this fraction with the letter k, and if you call this expression with the letter b. And then your equation becomes y equal kx plus b. That's the reason, because of this little link, simple link from here down to here, we call this bigger equation, this one, we call this Cartesian equation of the line. Let me just alter this example a little bit. Let me just imagine that here I have a vector like this. So I have another vector like this here with the components 0, 6, and -4, like this. So I just altered it for you, right? If I have something like this, what will be the change here? Formally speaking here I should write something like this. X take 2 divide by 0. This doesn't make any sense, it's true. And well, it depends how lenient your tutor will be. Sometimes books even write it like this. You can put some sense into this. But you can actually say it the other way with no any opportunity for the tutor to penalize you for that. You can say it like this. For this to make sense, it's sort of like a limit thing. When you look at the limit, sometimes when you have 0 and 0, you end up with a finite number, right? So in this case, it's a little bit of an informal argument, but in this case, when you have something where you have 0 at the bottom, you just say that x must be just 2. So in fact, your Cartesian equation of the line will have this form, x equal 2, and then the rest of it will be this equation. So equation of the line, of the line with this b, with such b and such a, the proper way to present the Cartesian equation of that line will be take this identity first, and then you take this identity, y plus 3 by 6 equal z take 5 by -4. So the Cartesian equation of this new line, of this modified line, with this new b vector, will be two equations, in fact, combined together, these two. That would be the proper answer, which doesn't let any tutor to penalize you for that. And in fact, it's nothing wrong with saying this, because in fact, if I put here, if I take this b vector, which means in this answer, which I didn't put for you, but you can probably imagine what will be here, lambda will be gone. It means that the first component is simply 2 for all lambdas, right? So that's what I just said here. First component simply 2 for all lambdas.